This is the first time we get to orbit Mercury. Out there at the forefront of our solar system lies Mercury, a small, uninhabited planet wrapped in a web of intrigue and mystery. At a mere glance, nothing seems significant about this planet. However, recent investigations by NASA have revealed some shocking revelations about Mercury that no one expected. Some of the mind-blowing discoveries, including data from the James Webb Telescope, have sparked controversy within the scientific community, with many hinting at the possibility of extraterrestrial species hiding on the planet. Amidst the chaotic revelations and bizarre conspiracy theories, a new plan is springing up within the scientific community. It is the master plan to strip Mercury of its mind-boggling masks and reveal its dark secrets once and for all. What mind-blowing secrets have scientists discovered about Mercury, and what revolutionary plans does the scientific community have for this mysterious galactic neighbor? Join us in this video as the Webb telescope finally found what NASA was hiding on Mercury all along. Our solar system is more than just an intrinsic body of planets swinging in a cosmic mirror. Around each of the 8 planets that make up this enigmatic ring system lies fascinating features of its own. Although planets like Jupiter and Mars may have taken the spotlight with their astonishing significance, one other interesting planetary body that seems to be lost in the crowd is Mercury. Mercury is the planet that lies at the very top of the list of planets in order of closeness to the Sun. Its distance from the Sun is a mere 58 million kilometers compared to Earth's 150 million kilometers. Mercury is also quite tiny compared to Earth, measuring only 3,000 miles in diameter. Thanks to its tiny radius around the Sun, Mercury is the fastest planet to complete its revolution around the Sun at a whopping speed of 47 kilometers per second. The planet completes a full rotation in just 59 days. In other words, 1 year on Mercury is merely 88 days, or for 3 months on Earth. Mercury's small size and immense speed are just a few of its fascinating features. From a distance on the cosmic map, it even looks like a habitable planet. The small planet has always been intriguing to the scientific community, but for some reason, it hasn't garnered attention like most of its cosmic neighbors. The first recorded observation of Mercury was in 265 BC. Early astronomers like Zupus back in 39 also studied the planet. However, all the scientific community had in these early times were bits and pieces of data, as all of their research was conducted using substandard scientific equipment and ancient telescopes. It wasn't until the 1960s that real tangible data about Mercury came to light, thanks to the efforts of the National Aeronautical and Space Administration, now NASA. A few years ago, NASA revealed the first real images of Mercury to the public. These larger-than-life photographs showed Mercury as a celestial embodiment of beauty and complexity. But it didn't come cheaply. In fact, despite years of planning and constructed effort to explore Mercury, scientists were only able to glance at it. The truth is that scientists have a hard time spying on Mercury like they do on other planets because of its proximity to the Sun. The Sun's unforgiving rays and bright light can damage optical instruments like telescopes when they gaze at Mercury for too long. As such, scientists can only glance at the tiny planet for a few minutes at a time to prevent damage to equipment. Even the James Webb Telescope cannot point toward the planet due to its closeness to the Sun. It's quite enigmatic how this relatively small nearby planet is harder to study than the farther planets, all because of the temperature and gravitational pull from the Sun. Sending a probe to Mercury is more like a suicide mission than a stellar mission. The probe must adapt to the temperature, atmosphere, and gravitational pull experienced there. Otherwise, it will waste away. It would shock you to know that Mercury blazes around the Sun at a whopping speed of 30 meters per second. This time-shattering speed makes it the fastest orbiting planet in our solar system. And just so you know, this also poses a difficulty for spacecraft that intend to survey the planet or land on its surface. So far, only 2 space missions have had Mercury as its target. The Mariner 10, launched on November 3, 1973, and the Messenger, launched on August 3, 2004. Both of these missions were the brainchild of NASA, and they are the primary sources of nearly all the information we have about Mercury today. The Mariner 10 spacecraft conducted 3 flybys, each unmasking the cracked-up, crater-ridden surface of Mercury and shining light on its magnetic field. In case you're wondering, this spacecraft was equipped with 2 telescopes, spectrometers, a magnetometer, spectrometer, and plasma analyzer. NASA intended to glean as much data as possible from Mariner 10's visit to Mercury. As luck would have it, the probe slowly found its way to the small, fast planet. As Mariner 10 approached Mercury, scientists were amazed to see the chaotic surface of Mercury. It was ridden with lots of craters and ridges, much like our moon. The images from Mariner were mind-blowing, as Mercury turned out to be nothing like what experts had ever anticipated. Aside from the rugged, good planetary surface, the spacecraft also detected a weak magnetic field and an unusually large core. In all, the Mariner took over 2,700 images of Mercury, giving scientists a rare and unparalleled view of the fascinating landscape. The second flyby of the Mariner was on September 21, 1974, during which it captured the southern polar region of the sensational planet. The last flyby of the Mariner 10 was in March 1975, after which it stopped transmitting signals to Earth. Later investigations revealed that the spacecraft had exhausted its supply of gas, and so was unable to make any more rounds. The magnificent work of the Mariner 10 was continued 30 years later when NASA's Messenger took off to the not-distant planet. Unlike its predecessor, Messenger didn't just conduct a flyby but also managed to orbit the planet. Thanks to this, scientists were able to gather more in-depth and interesting data about the planet. Armed with the interesting pictures of Mercury, NASA sought deeper data with this mission. This time it wasn't just about pictures. The agency wanted to know more about the atmospheric conditions and chemical composition of the planet. NASA also had to study the planet's magnetic field as well as dig deep into its geologic history and planetary core. As you'd expect, the Messenger probe was loaded with all the necessary gadgets it would need for this groundbreaking mission. Interestingly, the probe made 3 orbits around Mercury, during which time it took about 200,000 photos of the planet. These pictures were unique because, unlike the Mariner mission, they featured both sides of the planet. During the Messenger mission, the probe managed to enter well into the planet's orbit, hovering at about 250 kilometers above the planet's surface. This proximity enabled the probe to take pictures of both the light and dark sides of Mercury. After digging deep into the images and comparing them with data from the spacecraft's instruments, NASA found out that our dear sister planet had unusually high concentrations of calcium and magnesium on its night side. Moreover, the magnetic field of the planet seems to be weirdly distorted, appearing to be stronger and more intense in the northern regions. This weird pattern of the magnetic field puzzled scientists for years until deep research analysis was conducted to reveal the secret behind this anomaly. You see, Mercury's weird and unusual magnetic field is all due to how the planet formed at its core. Magnetic fields on planets are generated from the reactions that go on in their core. Take Earth as an example. The innermost parts of the Earth's core contain liquid iron. But towards the outer core, this iron changes to solid. The continuous or progressive solidification of liquid iron in the core is what causes a magnetic field. In other words, more and more solid iron is being formed in our planet's core every day as liquid iron cools and crystallizes to form solid iron. It interacts with the surrounding liquid iron. As this happens, as the Earth spins around its axis, a form of convective current is created. In the end, powerful electric currents are generated that produce a massive magnetic field stretching out into space. This is the exact mode of operation for the Earth and how its magnetic field lines are generated. For Mercury, however, it's a different ballgame. In fact, Mercury's mode of operation is so bizarre that it left scientists completely mind-boggled. In a recent research led by Hua from the University of California, Los Angeles, it was discovered that iron turns from liquid to solid at the core's outer boundary. This is very different from that of Earth, where the conversion from liquid to solid takes place at the core's inner boundary. Hua had this to say: "We had figured out how the Earth works, and Mercury is another terrestrial rocky planet with an iron core, so we thought it would work the same way. But it's not working the same way. It's like a snowstorm in which the snow forms at the top of the cloud, the middle of the cloud, and the bottom of the cloud too. Our study of Mercury's magnetic field indicates iron is snowing throughout this fluid that is powering Mercury's magnetic field." Further research showed that Hua's research was consistent with data from NASA's Messenger mission. The mind-boggling revelation led scientists to believe that planets have more than one way of generating magnetic fields. Although the cores of Mercury and Earth contain similar constituents like sulfur and iron, certain disparities in these two planets can produce astonishing differences as seen in their magnetic fields. However, the disparity between Earth and Mercury goes well beyond its magnetic field. You see, there are many other rules that this celestial body doesn't seem to follow. For instance, scientists were puzzled to find that temperatures on the planet could rise to values of over 430 degrees Celsius in the day, but drop to as low as minus 170 degrees Celsius. This puzzling scenario is due to Mercury's absence of an atmosphere. Unlike Earth, Mercury has a thin exosphere. Worse still, this exosphere is merely made up of atoms blasted off of its surface by impacting meteoroids and solar winds. Scientists believe that because Mercury is excessively hot, anything that would have formed a proper atmosphere over it gets quickly evaporated into space. Furthermore, since it lacks an atmosphere, the side of Mercury that's facing the sun gets blasted with extreme heat. And here's where it gets really shocking. One full day on Mercury is actually twice as long as its year. While 1 year equals 88 Earth days, 1 day actually equals 176 Earth days. So, this means one side of Mercury gets consistently bombarded with extreme heat and sunlight, while the night side barely gets any. These two factors, the lack of atmosphere and the extra-long day, are the major reasons for the extreme temperature fluctuations. The mesmerizing temperatures on Mercury have long caused speculations to run wild in the scientific community. Having a magnetic field and a rocky soil structure makes Mercury a possible inhabitable planet. However, the crazy temperatures would make life on Mercury practically impossible. However, certain controversial features of this enigmatic planet have left many wondering if there is a possibility of finding biolife on Mercury. And this has birthed questions like, what if Mercury is actually inhabitable, and if it is, what possible life forms could exist on the planet? So far, the surface of Mercury has proven to be quite interesting. Much like our moon, the planet seems to contain several impact craters. The moon has long been riddled with controversies and conspiracy theories of aliens, thanks to its unusually large number of craters, some of which take enigmatic shapes like Dome Mo. Although no proof exists of such extraterrestrial moon bases, many have equally begun to point fingers at Mercury, suggesting the existence of such species. Although impact craters are usually the fault of asteroids, it isn't impossible that some can be caused by spacecraft. For example, NASA's Messenger probe caused a massive crater when it crashed into Mercury's surface on April 30, 2015. Today, there are countless craters, cracks, ridges, and even traces of lava eruptions. And so, what if some of these other craters were caused by other similar extraterrestrial spacecraft or alien activity? Several other shocking facts about Mercury have also led to conspiracy theories, like the ice water deposits found in the bottom of the craters at the north and south poles of the planet. In fact, a new scientific study from the Planetary Research Institute showed that the planet's north pole might have the perfect conditions for extreme bioforms. These habitable areas feature conditions quite comparable to those on Earth, only that they're hidden beneath the planet's surface. This shocking conclusion was drawn from the analysis of the images from NASA's Messenger probe, which were developed into a map. Using this data, scientists discovered that there are certain salt glaciers on the planet that are packed with volatile compounds to support the existence of biolife. And so, even within the harsh environment and the deadly proximity to the sun, these experts believe that there is a chance aliens or some sort of bioforms can be found on Mercury if we dig deep enough. One of the most phenomenal achievements of NASA's Messenger probe is that it managed to draft a map of Mercury, capturing all the craters and basins that were on the planet's surface. This gave scientists at NASA ample opportunity to study the planet's geology in depth. But even more, the probe also managed to reveal the composition of Mercury. It turns out that the lonely planet has a surface composition of 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Scientists also discovered that the planet has an unusually high abundance of volatile elements like sulfur, but an unusually low amount of iron. This discovery sparked controversies within the scientific community, because it set Mercury apart as a different planet from the rest of the planets in the solar system. Generally, planets in the solar system are known to be more abundant in iron than sulfur, especially in their core. Seeing a planet that didn't follow this rule was quite unexpected and sparked intrigue in Mercury as a whole. Recently, scientists also noticed something unusual about the planet. It had a peculiar dusty ring about it. This once again sparked controversies. Many experts within the scientific community were concerned because Mercury seemed too small to have a planetary ring. In our entire solar system, only Jupiter and Saturn are known for their rings. Jupiter's rings are quite few and faint and were first detected in 1979 by Voyager 1. Saturn, on the other hand, has a well-defined ring system that can be spotted even from Earth. These rings consist of billions of small particles, though some can be notably larger, all circling around the Sun. The materials that make up Saturn's extensive ring system include water ice and rocky material. Scientists predict that the rings around Saturn and Jupiter were formed during the early dawn of our solar system. And even more, scientists believe that the colossal size of these planets played a very important role. Saturn is about 10 times the diameter of the Earth, and it managed to pull in a vast system of tiny rocks and particles to form a planetary ring. Jupiter, on the other hand, is nearly 12 times the diameter of the Earth, and it managed to pull in about 95 moons as well as form its own miniature ring system of tiny space objects. Given the colossal size of Saturn and Jupiter compared to Earth, it's understandable how these two giant planets managed to draw in all this cosmic matter and debris with their superior gravitational pull and stability. But then, this begs the question: how does Mercury, the smallest planet in our solar system, form its own rings? Just so you know, Mercury's dust ring is about 9 million miles wide. Scientists are still unsure as to how these rings formed. Many speculate, however, that they may be from meteorites which may have impacted the planet sometime in the past. A group of scientists led by Dr. Peter P., a research associate at JPL, admitted that this theory could very well be true. According to him, it isn't uncommon for different space objects to constantly crash into planets like Mercury that lack a significant atmosphere. So, it's possible some of these crashed objects may have released debris that over time became the visible dust ring we see today. Other experts in the scientific community also seem to agree, adding that the continuous weathering of Mercury's surface by meteor impacts and other cataclysms must have contributed to its small size and thin mantle. Notably, Mercury's outer shell, also called the crust and mantle, is quite thin compared to Earth. It is only about 250 miles thick. In comparison with the core, scientists found that Mercury's metallic core makes up about 85% of the planet's radius. As such, many brilliant minds hypothesize that Mercury must have suffered cataclysmic events that stripped it of its outer layer, initially leaving it as the tiny planet we see today. Nevertheless, all these are just assumptions. There's still a need for NASA and other space agencies to dig deeper into the cosmic fabric of Mercury to answer all of its puzzles. The Mariner and Messenger probes did humanity a favor when they overcame the harsh solar radiation and cosmic hurdles to take a quick peek at a planet that was thought inaccessible. Although it may seem insignificant compared to several other groundbreaking achievements of astronomers and cosmologists in recent times, the successful completion of the Mariner 10 and Messenger missions was a massive accomplishment. The intense heat and radiation these probes endured while getting readings off of the mysterious planet is enough reason for accolades. NASA employed state-of-the-art technologies for these missions, some of which were ahead of their time. Today, with far more advanced technology, plans are underway to dig even deeper into Mercury and unmask its deepest, darkest secrets. No doubt, the most mind-boggling of scientists' study of Mercury so far is its surface, rugged and totally bizarre with its excessive craters. It's easy to suspect that there's a lot more hidden within its enigmatic landscape. So far, only 500 craters have been identified and named out of the countless others on the planet. Some of the smallest of these craters measure up to 9 meters across with depths of up to 7 miles. Meanwhile, the massive craters can reach up to 963 meters across. This enigma can only be truly solved and explained through proposed research. Such research can only be conducted up close with a highly sophisticated spacecraft with state-of-the-art installations to do what neither the Mariner nor Messenger space probes could do. For now, The only other space mission that has its eyes set on Mercury is the joint mission between the European Space Agency and JAXA. The brainchild of this significant collaboration was named BepiColombo, and it was officially launched on October 10, 2018. The revolutionary spacecraft contains both a planetary orbiter and a magnetospheric orbiter, and its mission is to carry out a comprehensive study of Mercury, including its interior. The BepiColombo is officially slated to arrive at Mercury by December 2025. So, for now, all we can do is cross our fingers and sit still, hoping that this all-important mission doesn't go sideways. However, in the meantime, there's no doubt that Mercury is slowly stepping into the spotlight. In comparison to the other 8 planets, who knows, the BepiColombo might just make a groundbreaking discovery that will put it at the top of our cosmic research radar.